Five would be like the C, and we'd be saying five is a number between 2 and 7, and 5 is an element of the set 2 to 7. You guys all healthy?
Yeah. For the most part.
Pretty good. That nobody on the team yet is tested positive.
We had them like early in the year, like I had it.
Oh, that's right. I forgot about that.
Yeah, I only lost taste and smell though, which was good. Other kids had everything.
Okay.
How long did it last? I know a lot of, I heard people like still didn't have their sense of taste or smell like weeks after they had it.
Yeah, I still don't really have like bad smells, which is kind of nice, but it's weird.
That is weird. That
It's
is
weird.
weird.
So it's just messing with my brain.
That's really weird. Yeah. Yes. And that's been
It's been
4 weeks.
about a month, yeah.
Crazy.
Yeah.
Make sure your fire detector is on.
Good point, Aiden.
Yeah.
Good point.
Yeah, but other than that, we haven't had any cases.
Okay.
It's that initial shock, like all of Jamie.
Yeah. Okay.
And everything's calmed down.
Okay. That's good. That's what I want to hear.
Yeah.
That's exactly what I want to hear.
Hopefully they come back negative today and then next week.
That would be, yes, that would be.
Next
awesome.
week will be interesting.
Yes, that's. Oh.
Good morning.
Good morning.
See if I can. You're right. I know I'm right. That's not good. Okay.
My daughter's texting me. This can never be good. I only get texts from them when they want something.
Did you bring her from Miniature?
to order today. We have time.
I know. Oh my goodness.
All right, all right. Hopefully everybody had a good weekend. Hopefully everybody had a good weekend. Okay, how many people think the dashboard, the COVID dashboard may light up after next weekend? How many people think that?
You mean this
co-
weekend?
This weekend, sorry, yeah, this weekend. Oh, I need to get mine so I can see my. Sure, I started this for all those who. Okay, hopefully it won't happen. Hopefully it won't happen. This is at least what I'm hoping. What's next Tuesday? What's next Tuesday? Not this Tuesday, but next Tuesday.
Election day.
Election day, election day. So yeah. So while I am not political, I do encourage everyone to vote. I encourage everyone to vote. You can vote here in town. You can vote. They usually have some kind of polling station over in one of the, I think it's over in Convo. I think that's where it was last time. Okay, if you can get your videos on, get them on. If you can get your videos on, I want to see your lovely faces. It's easier to teach a face than a name. It's easier to teach a face than a name. I guess let's start by standing up. Let's just stand up. Stretch. Okay, let's sit back down. Okay, number one, I want to get details down because I'm ADD. We are going to have Quest 3 on Friday. Quest 3 Friday. Now guys, I'm only going to give you I'm only give you like 30 minutes for it. I'm going to teach 20, Quest 30. What did I just say? Teach 20, Quest 30, okay? It's going to be over these sections. 3.2, which is product rule and quotient rule. 3.3, which is chain rule, power chain rule. 4.1, which is what we're going to talk about today. And it won't be all of 4.1. It's going to be primarily increasing and decreasing, finding intervals of increase and decrease. Okay. And then the average and instantaneous rate of change. When they ask for the rate of change, in your book, they mean instantaneous. What tool do you use to find the rate of change? The derivative. That's what they're asking for. The derivative at a point. When they ask for the average rate of change, and I'll be very specific on the quest, what flashcard do you want to remember? Average rate of change on the interval A to B is... It is the slope.
Dr. Warren,
Yes.
would you mind taking a picture of the board and posting it later in files, just because it's a little bit difficult?
Sure. I'm taking a video, so there'll be a video on YouTube that'll be a lot clearer. There'll be a
Okay,
video on
great.
YouTube, so you can just have it written down there. In fact, you might even see me writing it.
I usually watch the YouTube videos when I come home, but
That's
I didn't know if it was gonna show it all.
yeah. So I think it's pretty clear. The video. I know in Zoom, it's all dependent on your feed, how much bandwidth you guys have, which is what's hard. And guys, I'm looking around the room here, and I probably have like 10 people here, but I've got 22 chairs. So if you're like somebody who likes to be in class, learns better when you're in class, I would say come to class. I'm almost certain there'll be a desk for you. Okay, so I just want to leave it out there. There's no reason if you want to be in class not to come to class. Unless, of course, you have COVID, then don't come to class. Okay, or you've got the flu, don't come to class. You have a stomach bug, don't come to class. Okay, The classic things, don't come to class. So what is the formula? Flashcard for Friday, you wanna have down. You see the word average rate of change, bing, you say
F of B minus F of A over B minus
F of B minus F of A over B minus A. I say tangent line, you say, I hate you, Dr. Warren. No, I say tangent line, you say,
I minus F of C equals F prime of C times X minus C.
yeah, so those again are fair games. Those again are fair games. Okay, again, Quest Friday, 30 minutes. 3-2, 3-3, 4-1. Increasing and decreasing only. Increasing and decreasing only, which is what we're going to talk about today. And average and instantaneous rate of change. I've only got 30 minutes. So I can't put tons of problems on there. Okay, to motivate some of these definitions, I guess maybe we'll write down the definitions. So just get ready to scribe. Your job is to scribe. All you're going to be doing is writing. I'm going to read really slowly for you guys at home. If you were in the classroom right now, if we just had a regular class, I would just sit quietly and let you guys just write everything down. But since you guys can't read it at home, I'm going to read. This says DEF parentheses N. It means definition. DEF parentheses N. Okay, what we're defining here is a critical point. And I underlined that. A critical point of F, that's my function, of F on the closed interval AB. And Miles had a good question. He goes, Dr. Warren, is that an ordered pair? And I said, no, that's not an ordered pair, it's an interval. Like I could see the interval 2 to 7. That means all the values between 2 and 7. That means all the numbers between 2 and 7. Okay, so let's go back again. A critical point of F on the closed interval AB is a value C. That's a C. And this next symbol looks like this. The next symbol looks like this. And this is the word element of. That's what that symbol means, element of. It's an element of the closed interval AB. C is an element of the closed interval AB. Can you guys read this? Can you guys read this? Such that either f prime of C equals 0, or f prime of C does not exist. Either f prime of C equals 0, or f prime of C does not exist. And you're like, well, Dr. Warren, when does a derivative not exist? So ask me that.
When does the derivative not exist?
Okay, if you lose continuity, you don't have differentiability. So anytime you have a break in your function, of any kind, you're going to lose differentiability. The derivative won't exist. Okay, the next thing is anytime you run into a corner point, you're not going to have differentiability. You say, well, Dr. Warren, why with a quarter? Can you guys see this right here? Can you see that? Is that off the, can you guys still see that part of the board? That little tiny piece right there? No? How about, well, I'm afraid I'm gonna have my board. I guess, can you guys see over here? Can you see over here? Can you see that? Okay, so imagine I've got a quarter point on a function. Imagine that I've got a corner point. The derivative's not going to exist there. And let me try to explain why. The derivative is defined in terms of does anybody remember? The derivative is defined in terms of calculus is about limits, derivatives, and integrals. The derivative is defined in terms of a limit. The limit exists if and only if the left-hand limit's equal to the right-hand limit. Does that make sense?
Yeah.
If and only if the left-hand limit's equal to the right-hand limit. But remember, graphically, the derivative represents the what of the tangent line. Dr. Warren, I'm not focused. Graphically, the derivative represents what for the tangent line? The slope. So you can imagine that I'm coming in to talk about the slope of that tangent line. If I'm coming in this way, the tangent line looks roughly like this. But if I'm coming in from above, the tangent line looks roughly like that. Do these two lines have the same slope? So the limit, the right-handed limit's not going to equal the left-handed limit, so that limit's not going to exist, which is mean the derivative's not going to exist. So anytime you run into a corner point, your derivative's not going to exist. So Dr. Warren, read this to me one more time. Yeah, okay, let's see if you guys have it. Definition, a critical point of f on the closed interval AB. You guys aren't reading at home, none of your mouths are moving. Is a value C, an element of closed interval AB, such that f prime of C equals 0, or f prime of C does not exist. You see, Dr. Warren, what does f prime of C equals 0 look like? Well, what does the derivative represent graphically again? The slope of the tangent line. What does a line of slope 0 look like? What does a line with slope 0 look like? Yeah, a flat line. I like to call it a dead man's line. You're like, Dr. Warren, why would you call that a dead man's line? Because I think of an EKG. And a dead man's EKG looks like what? You remember flat line? You ever heard of flatliners? Okay. So I think about anytime I have a tangent line, where it's flat, that has a derivative of 0. Like, for example, a parabola. If I look at a parabola, down here at the bottom of the parabola, the tangent line would be 0. The tangent line would have a slope of 0. Does this make sense? Does this
Yes.
make sense? Okay. Okay. Next, definition. DEFN. F is increasing. We've talked about this already. On the closed interval AB, F is increasing on the closed interval AB if and only if for all, read that, x1 and x2, x1, comma x2, that are elements of, that's an element of, the closed interval AB, for all x1 and x2 that are elements of the closed interval AB, such that x1's less than x2, it implies that f of x1 is less than f of x2. And again, we talked about this last time. We talked about increasing, why that made sense to be the definition of increasing. Decreasing is the same definition, exactly the same words, word for word, until this last inequality. Definition, f is decreasing on the closed interval AB. If and only if, for all x1 and x2 in the closed interval AB, such that x1 is less than x2. You're like, Dr. Warren, that's the exact same thing you wrote down. The only difference is that it's not f of x1 less than or equal to f of x2. It's f of x2 is less than or equal to f of x1. So guys, I'll remind you, just draw a function that's increasing. Give yourself an xy axis. And draw a function you think is increasing. We'll just do this again. Mark an A and a B on there. Mark an A and a B on there. Now pick an x1 and x2 on that x-axis with x1 less than x2. So all we're doing is laying out this definition. So you mark an A and a B, pick an x1 and x2 in between A and B with x1 less than x2. Now mark f of x1 and f of x2 on the y-axis. Now mark f of x1 and f of x2 on the y-axis. Who's higher? Who's higher on that y-axis? Who's higher on your y-axis? F of x2. And so that's meeting that definition. Do you see how that meets that definition? Now do the exact same thing, but make a decreasing function. Do the exact same thing, but draw a decreasing function. Again, make x1 less than x2. Again, make x1 less than x2. Now mark f of x1 and f of x2 for this function on the y-axis. Mark f of x1 and f of x2 for this function on the y-axis. What do you notice now about f of x? Who's higher now? Who's higher now for this decreasing function? Who's f of x1? And that's what this last inequality is saying. This last inequality is saying f of x1's greater than or equal to f of x2. So does the definition make sense? Does the definition at least visually make sense? Here's the problem. Here's the problem. This is almost mathematically impossible to show. Using the definition to show increasing and decreasing is almost impossible. What did I just say?
It's almost impossible.
It's almost impossible for even easy functions. So we have this amazing theorem that we derived last time. At least we derived case 1. The theorem says this. We'll deal with these guys in a moment. The theorem says this. If f prime of x is greater than 0, if you know that the derivative is greater than 0 for all x in the open interval ab, for all x in the open interval AB, then that implies f is increasing on the interval AB. One more time, Dr. Warren. It's blurry at home. Theorem, TH parentheses M, part 1. If the derivative is positive for all x in an interval, then the function's increasing on that interval. 2 is almost exactly the same. 2 is almost exactly the same. If the derivative is not positive, if the derivative is negative on the interval for all x in the open interval AB, then instead of increasing, it's decreasing. Okay, and again, we used the definition of the derivative last time to get that. And then the last one we didn't really talk too much about. If the derivative is always 0, if the slope of the tangent line is always 0 for all x in the interval AB, the derivative is equal to 0 for all x in the interval a to b, then the function has to be a constant. Then the function has to be a dead man's graph on the interval a to b. Then the function has to be a dead man's graph. Miles.
So the theorem, all those are open intervals, right?
Yeah, they're open intervals. We don't think so much about the closed interval on those.
Okay.
Yeah,
And
okay.
does that like matter for what we're?
It does in another course, but not in this course. So yeah, it does. It's a great question, Miles. Okay, now hopefully we'll talk about these last two. We'll talk about these last two in a moment. What I want you to do now is draw this graph. At home, you guys draw this graph. This is 5, 10, 15, 20, 30. And then you've got 3, 5, 9, 10, 11, and 12 there. Draw that graph. So just draw that graph. Can you guys see the graph at home? Can you see that graph at home? Kind of. So it kind of goes up, down, jumps, goes up, swings down, asymptote, goes way up to infinity, comes jumping off at minus infinity, goes up, down, up. way, because I draw the graph and I stand in the middle of the board.
Dr. Warren, is that point at 3 and 20, the first point?
The first point is at 3 and 20, yeah, basically.
Mhm.
This maybe is like at 22. Doesn't really matter, the height of this, so it doesn't matter so much, but. This is why it's so nice to have students in class, because I can see how long it's taking them to draw, so normally I'd be blazing on, so it's good to.
What is written on at the end of the x-axis?
Oh, okay, yeah, this is, Lorelei, that's time and that's months, time and months. Time being measured in months. And on the y-axis is, can you guys see that symbol on the y-axis is? Money. Okay, now let's just look at this. Now I didn't tell you what this was. But imagine that this is IBM stock. Imagine that this is a graph of IBM stock over 2020. Imagine that this is IBM stock in January and all the way through to December. So this is IBM stock. Okay. Now if you're looking at all the different times, there's infinitely many times, milliseconds in between here and here. But if you had to pick the days that were the most interesting for this stock, if you had to choose days that were the most critical for this stock, which days look the most interesting? I mean, which days look the most
Do
interesting?
you mean months?
I mean months, yeah, I mean months.
Looks like October's pretty interesting.
Yeah, it looks like, how about here? I mean, let's talk, what's going on with IBM over the first 3 months?
Increasing.
It's increasing. Is that important? Is that
Yeah.
important?
Yeah.
Okay, now it's March. Now what happened?
Increases.
COVID. Instantly, now it's decreasing. Is COVID day important? Is the COVID month important? Does that seem interesting?
Yes.
Because it was going up and now it's going
Down.
down. Okay, now what happened to May?
Jumps up.
Jumps way up.
Yeah, is that an important day? Does that day seem important?
Yeah.
Yeah, stimulus. Stimulus gets released. Now it jumps immediately in price, and then what happens?
Increases a little and then drops a lot.
And then drops a lot because we're not social distancing. Okay, nobody's social distancing. This is July when we realize, oh crap. Okay, and now it's September, and then what happens?
It's at a low, but then it jumps.
Does this seem like an important day? Does this seem like an important day?
Month.
And does this seem like an important month? Does this seem
Yes.
like an important month? Whenever that is. Okay, does October seem like an important month?
Yeah.
Yeah.
Yeah, all hell broke loose. You know, this is not physical, right? There's no way you can have it be worth an infinite amount of dollars and then be worth a negative infinity amount of dollars. So we know that something went wrong with the computer there. Okay, then what starts happening?
Goes back up.
Goes back up. Seems like that would be pretty interesting. And then what happens? Shoots back down. Does that seem pretty interesting? And then it starts going back up. So if I'm thinking about the most interesting days, if I'm marking them, I'm saying, okay, that day looks pretty interesting. Something drastically changed at that point in time. Right here, that looks really interesting. We had a massive jump in our price. This looks pretty interesting right here because we were going up. This day looks interesting. We hit a max and then we started going back down. This day looks interesting because we hit a min. This day, it's interesting, but it's not really physical. It's not really physical. This day looks interesting. This day looks interesting because we maxed and we started going down. This day looks interesting. And as far as all the days, those look like the most interesting days. You're like, this day's like, hey, I'm interesting. I'm interesting. Not really. Sorry, you're not interesting. Because we're just going up and you continue to go up. It's not that interesting. Now notice, what did I just say? I don't know why I think if I talk in a real loud, monotone voice, that's good teaching. There's high quality teaching. I was telling my wife how I brought heroin into the lecture on Friday, and she's like, what? What did you do? And I'm like, I'm not quite sure how it happened. I just remember mentioning those words in class. And I was hoping that it was like in a negative way. It wasn't a negative way. We never do
Heroin.
right, okay, we never do heroin. Okay, just making sure, just making sure. Okay, so now back to where we were here. What do you notice about the derivative at this point? Does not exist. What do you notice about the derivative at this point? Does not exist. It's not continuous. What do you notice about the derivative at this point?
Zero.
It's 0. How about the derivative at this point?
Zero.
Here, it doesn't exist. But guys, this is not in the domain. This guy's not even allowed to play. He's not even allowed to play. How about the derivative here?
Zero.
How about the derivative here?
Does not exist.
Does not exist. Look at the definition. What do we call this point? What do we call these points again?
Critical points.
You get to be a critical point if you're in the domain, and either your derivative is
Zero.
0 or...
Does not exist.
Does that make sense? I mean, graphically, does that make sense, what we were looking at
Yeah.
there?
Yeah.
So I look at it as joining a sorority, okay? You want to be a critical point. You're in the critical point sorority. First of all, you've got to be a JMU student. Make sense? That makes sense if you're going to be a...
Yeah.
Okay. Second of all, you're either boring, but really stable. Do we need those people in the sorority?
Yeah.
Somebody's got to run the thing. Or you're lots of fun. Or you're lots of fun, okay? We want both types in our sorority. You're either boring but stable, or you're lots of fun, okay? And so we see here, this person, 3 gets to be in the sorority because she's fun. 5 gets in the sorority because she's
Fun.
fun. Whatever. 7 gets to be, 6.5 gets to be in the sorority because she's
Boring but
boring,
stable.
boring but stable, running the thing. Treasure. This is your treasure. Okay, this one's
Boring but stable.
boring but stable. Yeah, I don't know why this one's in here. She's a downer. Okay, this is like the person like, oh, okay, you're not really. Okay, now this person is not even in JMU. This person's like, this is the person showing up at the party, and you're like, wait, what are you doing here? You're 50 years old. You shouldn't be at this party. No,
No.
you're insane. This person's in the sorority because they're,
Boring but stable.
and this person's in the sorority because
Lots of
they're
fun.
lots of fun. Okay, does this make sense? Does this make sense?
Yeah.
How you get to be a critical point? How do you get to be a critical point? Okay, now, on the interval 0 to 3, is the function increasing or decreasing?
Increasing.
In between 3 and 5, it's,
Decreasing.
in between 5 and this number, it's,
Increasing.
in between 5 and 9, it's,
Decreasing.
how many people are getting increasing and decreasing? How many, like, if you look at it, you're like, I think I got that, Dr. Warren. Now that's fine if I give you a graph. Now, I did assign some homeworks with graphs, but guess what? Most of the time I'm not going to give you I'm going to give you a function. And is that going to change the game?
Yes.
Mhm.
Okay. So that's where the theorem comes in. If the derivative is positive, the function is,
Increasing.
if the derivative is negative, the function is,
Decreasing.
if the derivative is always 0, then the function is a constant. I don't really have the third case at all here. I've got places where the derivative is 0, but not always 0. Look on the interval 0 to 3. Would the derivative be positive or negative? Look on the interval 0 to 3. Would the derivative be positive or negative?
Positive.
Okay, in between 3 and 5, would the derivative be positive or negative?
Negative.
In between 3 and this star, it would be, in between here and 9, it would be,
Negative.
Okay, in between here and the not person allowed, it's positive, something, woo! Okay, and then in between here and here, it's woo! In between here and here, it's in between here and here, it's. So can you guys look at a graph and determine at least the sign of the derivative by what we talked about here? Okay, good. Okay. Check the time. 12:30. I'm letting you guys out 5 minutes early today. That will be at what time? 12:45. So you gotta let me know. You gotta let me know when it's 12:45. Say, Dr. Worm, we're done, okay? Paris, I'm putting you on that.
What? Okay.
12:45, okay.
What do I do?
Okay, I think what I'm gonna do, I'll save these definitions for Wednesday. I'll rewrite them. I'll rewrite these on Wednesday. I guess I've written them down. No, I'll rewrite them on Wednesday. I'm ADD, sorry, okay. So now what I want you to do is I just want you to turn to a brand new sheet of paper. Turn to a brand new sheet of paper.
Dr. Warren, I have a timer set.
Oh, you're awesome, Paris, thank you. Okay. Now, what I'm gonna do is I'm gonna share my screen with you guys. I'm gonna share my screen. Oh, come on. All of you. Okay. So let's look at, can you guys see that yet? Are you able to see that at home? Can you guys see this or not? Okay. So they're asking here, let's get rid of the answer. Okay, let's look here. They're asking here, given the graph, determine when it's increasing, constant, or decreasing. Let's look at number 2. On what intervals is the function decreasing? From negative infinity to -1, it's going down. When's it constant? When's it a dead man's graph? -1 to 1. When's it increasing? Don't you wish that was the whole test? Don't you wish that was the
That
whole
would have
test?
been great.
Now let's look at number 3. When's it increasing? -2 to 1, and they really want you to pretend that this goes on forever. Negative infinity to -1. When else is it increasing?
1 to
One to positive infinity.
1 to positive infinity. When's it decreasing?
-1 to 1.
-1 to 1. And did we get the right answer? Did we get the right answer? Okay, enough with graphing. Oh, I guess here, it says, okay, look at the following graph. Is f prime of 2 positive or negative?
Positive.
Because it's increasing there. F prime on the interval 1 to 3 would be
Increasing. Positive.
positive. F prime of 4 would be
Constant. 0.
0. F prime on the interval 3 to 6. F prime for every value on the interval 3 to 6 is 0, so the function's constant. Okay, we got it, Dr. Warren. Okay, so now let's look at this one. In exercises 14 through 37,
Okay.
14 through 37, find the intervals where the function is increasing and where it is decreasing. Okay, so now we're gonna go after problem number 21. So write that down. G of x equals x cubed plus 3x squared plus 1. And we're gonna find out when that function is.
Well, wait, you
Oh crap, I just made a mistake, didn't I? Share again. Okay, number 21. X cubed plus 3x squared plus 1. And they want us to find when it's increasing and decreasing. So you guys have it written down? Do you have it written down? Because I don't, and you're gonna tell me what it was. Okay, so let's let g of x, and what was it again?
X
X
cubed plus 3x plus 2 plus 1.
Plus 1. Okay, let's make this more fun. Let's give it units.
No.
What's x? What's x? What's x? What's your domain units? Anything, 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 anything.
Pumpkins.
Pumpkins, okay. So pumpkins, and then f of x, your range units, your y-axis units. What do you want it to be?
Pies.
Sounds like pumpkin seeds.
Oh, or
Seeds. Okay, I like that. Seeds. So we've got, this is representing somehow pumpkins and seeds, okay? X is measuring in pumpkins, X is measuring in pumpkins, and Y is measuring in
Seeds.
seeds. And we're asking, you know, on what, how many pumpkins, on what range of pumpkins, on what domain of pumpkins is the seeds, are the seeds increasing, and what domain of functions is it
Decreasing.
decreasing? Now, of course, this is not physical. Okay, how many people want to graph it to find those intervals? How many people want to graph it?
No.
And I see nobody's hands in the air. I see nobody's hands in the air. However, if we can find when the derivative is, if we can find when the derivative is
Greater than 0?
greater than 0, would that be good? Would that be
Yes.
good?
Yeah.
If we can find when the derivative is less than 0, would that be good?
Yes.
Okay, so how many people think they could take the derivative of this really complicated function? Do that. Tom, find the derivative of that.
But it's so hard, Dr. Warren.
It is so hard. If you've been drinking.
It's like 7 in the morning, or 12 in the morning.
Okay, how many people are done? How many people are done? How many people are done? Will this be on the quest? Will this section be on the quest?
Yes.
Increasing and decreasing. Okay, so you guys tell me, what did you get?
3x squared.
Okay. All right. Now, I want to find when the derivative is positive, and I want to find when the derivative is negative. And I'm going to teach you a technique to do this. The first thing we want to do is find the critical points. What did I just say? You get to be in the sorority if your derivative is 0 or your derivative does not exist. In Math 205, it's almost always you're in the sorority because you're boring. Okay? There's only very few cases where you get in because you do not exist. Like, for example, is there any division here at all? Is there any division here at all? So there's not really any way to make this derivative not exist. There's not really any way to cause division by 0 with this. So I've got to figure out when is this derivative equal to 0? So that's step 1. Well, step 1 is really take the derivative. Step 2 is set your derivative equal to 0 and find those values of x. So let's set my derivative function equal to 0. How many people feel like they could do that? How many people think they could set that derivative equal to 0 like that? Okay, the next step is almost always factor. The next step is almost always factor. So set your derivative equal to 0. Step 3 is almost always factors. Occasionally it's a little more involved. This is not that bad to factor. You don't even need to factor it into binomials. What's the greatest common factor between 3x squared and 6x? 3x. So let's factor that out. And what are you left with? What are you left with, guys? Do the algebra. What are you left with when you factor a 3x squared out here? X plus 2. How many people are with me? How many people are with me so far? Okay. Now this is the most important part. This is the most important point, is what I wanted to say. What did I just say? What did I say?
The most important point.
Look at you guys, bless your hearts, you're all yawning at home. I'm sorry, I'm sorry. I've done this to you. And they're yawning here too. I just can't see it, they're in masks. I'm yawning too. Or spreading COVID around the room. I'm not really sure which one I'm doing. This is the most important point. I'm giving you guys the power to focus. Woo! I just gave you, Miles, the power to focus. Okay. Draw a number line. Draw a number line. Beside this number line, put G prime. It's going to be a sign chart. It's going to be a sign chart for G prime. It's what we're going to read to answer the questions. It's what we're going to read to answer the questions. Okay, now, what are the only two values that could make my derivative 0? Look at it. I've got this times this is equal to 0. Algebraically, that means either this has got to be 0 or that's 0. Because if they're both not 0, you multiply them together, you're not going to get a 0. What value of x would make 3x 0?
0.
So put that down on your number line. So I have 0 there. And I know that makes my derivative 0. So I like putting that up there. I like putting that up there. That helps me. Now what other value of x? What other value of x would make your derivative 0?
-2.
So let's put that on my number line. Okay, and I don't know how many times I say this, but I don't think it registers with most students. I say it over and over again, but I don't think it registers. More importantly than this is zeros. More importantly, it's 0 at 0. More importantly than it's -2 at 0, is these are the only places it's 0. What did I say?
These are the only places it's 0.
Algebraically, there's no other value of x. There's no other value of x that will make it 0. It's either 0 or -2. You're like, that's one, who gives a crap? Well, let's just see. Let's test one number bigger than 0. Give me a number bigger than 0 over here. 1. So let's test 1. Let's put it in my derivative form. 3 times 1, positive or negative?
Positive.
1 plus 2, positive or negative? Positive times a positive.
Positive.
So at 1, it has to be positive. You're like, well, Dr. Warren, how does that get more importantly than a 0? It's the only place that it's 0. Well, suppose it ever went negative. You'd have another, we know it's positive at 1. Suppose that at like 25, it's negative. Well, then there'd have to be somebody that's 0 in between. Does this make sense?
Yeah.
If you're positive here and you're negative out there, somebody's got to be 0 in between there. But these are the only zeros. So I know that the derivative is positive for all of those values. Is that useful? Is that useful? Now I know this is hard. Give me a number in between -2 and 0. -1. Now let's test that. 3 times -1. All I care about is positive or negative. 3 times -1. -1 plus 2. Positive or negative? Negative times a positive. Negative. I know then everybody's got to be negative. Everybody has to be negative between -2 and 0. Okay, just one other value we just have to test. Just one other value. -5. I like that. -5. Now you guys are going to help me. 3 times -5. Negative or positive? -5 plus 2. Negative. Negative times a negative is a positive. So there's my sign chart. My derivative is positive from a -infinity to -2. The derivative is negative between -2 and 0. and the derivative is positive between 0 and infinity. But if the derivative is positive, then the function is, thank you, increasing. If the derivative is negative, the function is decreasing. So I'm decreasing between
Negative two.
-2 and 0. I'm increasing from 0 to infinity, but also negative infinity to negative. Does this make sense? Does this make sense?
Yes, but how do
Okay.
we write it?
What else?
How do we write that though?
So you would write it like this. This is the way they want it. They would say from -infinity to -2, okay? And then they would probably use closed brackets for that, because it can go either way. Then they'd go from, that would be increasing, and then I'm also increasing from 0 to infinity. And then bring those together, I'd put that.
And you just write that for like increasing, decreasing.
This would be increasing,
Flat.
and then decreasing, because it's an interval idea, decreasing is between -2 and 0. And as long as it's in the domain, you just close them in. Okay, guys, okay, we will pick up with this on, Wednesday. We'll pick up with this on Wednesday. Thank you.
Do we not write when it's constant?
Excuse me?
Do we not have to write when it's constant?
No, you don't have to write them as constants for this one. You don't have to write them as constants for this one. There was no place where it, was 0 on an interval. But we'll pick up with this. We'll be doing the same thing on Wednesday. We have a quest win.
Friday.
Thanks, guys.
Thank you.
Thank you, everyone.
You guys are great.
Thank you.
Dr. Ward,
Yes.
can I talk to you at the back?
Is that Christian or Nicholas?
I'll get that.
Nick, what'd you say?
Can I say, can I talk to you, after class is over?
Nick, I've gotta go. I've gotta meet some, that's why I'm letting class out early, but I have, thanks, Aiden. See you guys. So I have office hours at 2. So it's a Zoom office hour, Nick?
Yeah.
Okay, so we could definitely meet in there if you're free at 2.
Okay, would it be the same Zoom link as class?
It's in the announcements instead, it's because it changes. So if you just go to the announcements, there's an office hour link in there.
Okay.
All right? Thanks, Nick. Oh, lordy. Oh, I'm sorry. Oh, it's just so much work, it's so much